Hi everyone, and this is going to be a short video going through critical dimensions in engineering required for your technical sketching portfolio. So let's jump into it. So this is something that we have gone through in the lecture, so I'm not going to go into too much detail about it, but I just wanted to rehash it for a bit of context for the next two particular example slides. So critical dimensions. So when designing, you as engineers must decide what elements of the design are critical to the function, and therefore what dimensions require closer attention during the manufacturing process. So if you identify too many dimensions, what will happen is the part will require additional inspections, increasing the cost unnecessarily. Similarly, if you identify too few dimensions, quality could be compromised and the component may not work as it was intended. So the determination of critical dimensions, that will come with practice, and it's very similar to everything else you've been working through in Mech 1110, such as your technical sketching and CAD modeling skills within Creo. Okay, so let's come through to an example. So critical dimensions as an example. So what we're going to look at firstly is the drill press collar. So what you want to try and think about is how the drill press collar will assemble to other components. So you want to think about how it may assemble to different components. So this will basically mount, if you like, into this cylindrical section, and this thickness may be important here. So we'll run through that in a little bit more detail shortly. So the best way to think about critical dimensions is you want to, in your mind, set a tolerance. So for example, let's set a tolerance of plus or minus 2 millimeters to all dimensions. So once you've done this, what dimensions will actually be critical? So what I'm going to do is I'm just going to use the highlighter and we'll go to green. Okay, so now what we're going to do is we're going to quickly work through for what dimensions are critical in this case. So for this drill press collar, this inner bore, that's going to mount to essentially the quill of the drill, if you like. So it's actually going to mount to another component. So this 54 will definitely be a critical dimension here. So we definitely need to consider that one. The 68, because it's mounting to something, and if that was 70 millimeters or slightly smaller at 66 millimeters, probably not going to matter in this instance. So that one I'd probably leave as is, because if it's plus or minus 2 mil, that's going to be fine. Our M9, because that's going to probably merge with another component down here, that's going to be important. Also, these locations will be quite important, just to make sure that if it is interacting with other components, that they need to actually do what they are intended to do. The 30 millimeter width here, again, that's probably not too important. If you're 28 or 32 millimeters in this instance with our tolerance, it's not really going to matter to this particular item. The thickness here, if they are 20 millimeters, that's going to be quite important because that could be going between two surfaces, for example. So once you put this drill press collar in, it may be basically wedging between two surfaces, if you like, and then tighten together. So the 2 millimeter gap is going to be quite important because naturally if you have a plus or minus 2 millimeter tolerance, it could either be 4 or 2. That could compromise the function there. Again, the 34 millimeters with our tolerance that's been set, probably not going to matter in this instance because if it's a smidge wider or a smidge narrow, probably doesn't matter. This is probably a bit of a redundant dimension, but because the thickness in this section through here, we would deem that to also be critical because obviously you just want it all to be flat. And then because a bolt would be going through here, our diameter 8 would also be the critical dimension there. So when we talk about those critical dimensions, the thing to think about is initially, what's it actually going to be assembling to? So try and have a think, and I do appreciate it can be a bit difficult when you've only physically got the product if you don't know what it's merging to. So just have a think about what may be going together. And again, we're here to help you work through these exercises. And then the other thing you want to do is to set that physical tolerance to think about plus or minus, if it's within 2 millimeters, we should be okay with some of these dimensions. And the ones that I've highlighted, they need to be pretty much spot on, or it may compromise the function there. So if I just clear the screen for that one, and let's move through to our next example. So the next example we're going to work through, and this should be something that's a little bit more familiar, is a security chain keeper. So something that you obviously put on the door if you put the security chain in. So a lot of hotels have this sort of thing. So again, if I bring up the highlighter, so again, you want to think about how the security chain keeper actually fits to the door, for example. And then you want to, again, we're going to set a tolerance here of plus or minus 2 millimeters to all the dimensions, and you want to determine what the critical dimensions will be. So when you're doing these exercises in your technical sketching portfolio, you also want to set a tolerance of about plus or minus 2 millimeters just to make your life a little bit easier. So again, the thickness of this plate, that's going to be quite important. So the 2 millimeters here, because naturally if we were at 0, doesn't exist, and if it was a little bit thicker, it may not work. So that's definitely going to be an important one. The 14 millimeters here, that'll be quite important, because if we're too narrow, we may not have enough material in this slotted section through here for it to physically work. So that's going to be another important one. The 11 mil either side, I'd deem that in this instance not to be critical. If you're at 9 mil, you're still probably going to have enough room to make some holes through here if you need to screw it to the door. And if you're a little bit wider, probably not going to matter in this instance. The length could be an important one depending where it fits onto the actual door itself. 85 millimeters, you probably wouldn't want to go much longer than that or much shorter, because again, it would then interfere with how much material's left between these two end sections through here. Because we've deemed the 14 to be quite important, the 18 would inherently be important there as well, because naturally if our 14 was going to be, assuming it wasn't a critical dimension, it was 16 millimeters, and then if we did deem that 18 to be a critical dimension, you've only got 1 millimeter of thickness left in here, so that's why we would deem that one to be important. The height with your 8 millimeters would be quite an important one as well, because if it's too shallow, you may not be able to get the actual the security chain into the slot itself. And again, our 2 millimeters here would be important because we want to keep the material thickness consistent. Our diameter 10 would be quite important, and that's just simply because we essentially have the security chain itself having to fit into that hole. So if the hole was too small, it's naturally not going to work. And in a similar fashion, our 6 millimeter gap here would be the same. The only other two that are here, so our 9 millimeters again, if that was a little bit wider or narrower, it's probably going to work for its function in this case. The only other ones left are these two 9 millimeter ones. So depending how you actually go here, so if you deem the 85 millimeters to be the critical dimension, then your 9 millimeters, you could probably leave those because they're going to be within a bounds from the edge of the material, and it's still going to work. However, if I go through and just assume that 85 isn't going to be an actual critical dimension, because if it's a smidge longer or a smidge shorter, we don't really mind. These 9 millimeters would then be important because you want to make sure that you've got enough material from the end of that particular hole back to the edge surface here. So I'd probably deem these two 9 millimeter sections to be the critical dimension and not worry too much about the 85. Or vice versa, you could work to the 85, and then if those holes are a little bit out of place in the plus or minus 2 millimeters, you're probably not going to care. But for this particular case, I would probably work to the 9 millimeters here and go through and make sure that they're fixed in place. And then if the overarching length of the thing, the 85 millimeters, is a bit longer or a bit shorter, we don't really care in this instance. So hopefully this particular example has given you a bit of an idea of how to start working through with critical dimensions. The thing to remember is set a tolerance in your mind of plus or minus, say, 1 or 2 millimeters. For the exercises you're doing, I'd probably set them to be 2 millimeters. And then think about what the consequences would be if it was either plus 2 millimeters or minus 2 millimeters off the physical dimension you're looking at. And for the submission that you need to do for your technical sketching portfolio, all it simply needs to be similar to what I've done. You can just simply highlight the dimensions, and then we'll just probably ask you some questions when you're submitting that particular week's work in the computer lab session as well. So hopefully this particular video is giving you a bit of an idea of how critical dimensions work. Again, it's something that will come with a lot of practice, and the more that you do it, the better that you will get at it. And we're obviously here to help you as well work through these exercises. So if you do get stuck, please reach out, and we'll catch you in the next video. Thanks for listening.